All right. Good morning, everyone. My name is Kyle Escamilla, and I am the training coordinator for E&M. I want to thank you guys for attending the webinar today focused on 6 safety scanners and safety designer software. After the webinar this morning, we will be doing a short Q&A, so please type any questions or comments into the chat and we'll get to them at the end. Now I'd like to introduce your presenter for today's webinar, TJ Singh. TJ is a product specialist here at E&M. Good morning, TJ.
Thanks, Kyle. Good morning, everybody. And thanks for joining in for the webinar today. Like Kyle already mentioned, I'm the SIG product specialist at E&M in Southern California. I will keep the webinar very short and sweet. The agenda simply is to go over what safety scanners are, what they do, and what makes SIG safety scanners really special, our technology. And we do a quick look at our portfolio before we jump into the software side of the demo. So the very first thing is safety laser scanners. Like, what do you do with a safety laser scanner? For anybody who's new to scanners, it's simply to protect people. And essentially, it's a device that you use to monitor and detect any kind of a potential hazard or a unsafe condition in various different kind of environments. And you can use the device to trigger some kind of an alarm or a safety protocol to prevent those accidents and mitigate any kind of dangers. Another core thing to understand is the principle of safety laser scanners, the technology. So safety laser scanners typically work on time of flight technology. And to give a brief example of it, I'll go over an animation to show that. So how time of flight simply works is that you have, let's say in our case, a sensor. A sensor sends out a light pulse, which simply hits the object, gets reflected back to the sensor, and the receiver receives it. And then based on the time it took for that laser pulse to hit the object, come back, and since we already know that the speed of light is constant, we are able to calculate the distance of that object from our sensor. And what we simply do with traditional safety scanners is that we implement that same concept and add a rotating motion with a spinning mirror. And we are able to generate all these pulses in a 2D profile. But it's important to note here that in traditional safety scanners, we only get one single pulse of this light at every angular increment, which does mean that you lose some data or you do not get everything it's in the 2D environment because of the resolution. And you can get something called false trips. And this is where our SIG patent technology of HDDM comes into picture. So HDDM simply stands for high definition distance measurement. And again, to elaborate it with an example of a sensor, how the HDDM in time of flight works is that instead of a single pulse of light, what SIG technology does is sends out a packet of pulses of light, which hit the object and comes back. And that equals to getting more data points back. And when we implement this HDDM technology in our safety scanners, we are literally able to get a lot of data points, which means in between those angular increments, we are still picking up a lot of data. Now, once we have all this data, with our smart algorithms, we are able to make smarter decisions and hence very easily ignoring false trips, which essentially would mean for you guys is that our scanners are much more robust, be it ambient light, be it those welding applications where you might have a lot of flying sparks in the environment, or let's say even mutual interference with a lot of scanners doing cross talks. If you have them on the same plane, we do not have that problem because of HDDM technology. And even environmental hazards like dust, dirt in the environment are not going to trigger some kind of a false trip with our sensor technology. And this is a key point that separates us from all the manufacturers in the industry when it comes to laser scanners. Jumping into the portfolio now. So we came out with the first safety scanner almost 3 decades back in the 94s with the PLS. And you can see we have ever so evolved on the technology in terms of having the safe HTDM part, as well as in terms of form factor. And you can clearly see how compact the newer devices are. They're just getting smaller day by day with better technology. And real quick, talking about the portfolio, I'll talk about the popular ones. The first one is Microscan 3. Essentially, we have a lot of different variants in this, but they can be divided based on the range, which is we have a 4-meter variant, which means you can look up as far as 4 meters for your protective fields. Then we have 5.5-meter variant, and the longest range that we have is 9 meters. And in terms of integration, we offer basic IO capabilities. We also have FE Pro along with Ethernet IP with SIP safety protocols, and we have Profinet for ProfiSafe protocols as well. Apart from Microscan, we also have something called the Outdoor Scan 3, and this right now is the only safety scanner in the market that is certified for outdoor use, which means ambient light under sunlight or like fog, rain, all those tough environments are no problem because we have it certified for that kind of an environment. Even the Outdoor Scan 3 have a bunch of different variants. We do have IO capabilities on it, as well as Ethernet IP and Profinet for ProfiSafe, but the range on all the outdoor scans is 4 meters for protective fields. And jumping to the last scanner, this is the newest one that we have. It's called NanoScan 3, and you can see clearly the form factor is really compact, and it's like 3 inches approximately in terms of height profile, which means you can put it in any tough spot where you have space constraints. In terms of in physical interfaces, the biggest difference from our earlier products on this one is that we have a much more modular approach on this, which means that we have something called the system plug with this, and that allows you to choose the capabilities that you want for your application depending on your needs, and hence it's much more modular. Same in terms of integration, we do have your simple IO with OSSD outputs, and the newest variants also support FE Pro and Ethernet IP over SIP safety protocols. Lastly, in terms of application, again, for people who are not familiar with the safety scanners, the most common one are mobile hazardous area protection, where you might have an AGV, you can put it on top of that to protect it from colliding into something. Then you have safety for stationary applications, where you are doing area monitoring. If somebody is moving into a hazardous spot, you can protect them. As well as you can do point protection. So let's say you have a vertical you have a field where you are trying to protect somebody's hand. So you can install the scanner vertically, and it's going to detect their hand as well. And lastly, we also have access protection, where you're simply creating a virtual wall and protecting people again. And that's pretty much it in terms of the PowerPoint. Let me jump into the software side now. Yeah, you should be able to see my scanner now. And let me share my screen real quick. Okay. So this is the software, as you can see on the right. I don't know if it's still visible right now. Kyle, can you jump in?
Yeah, it's the software showing up right now.
Okay, perfect.
Yeah, and the camera's looking good too.
Okay, awesome. Thanks, man. Something with this Zoom thing here. Okay, so this is a software. It's called Safety Designer, And most of our safety devices from SICK work with the same software. It's pretty intuitive. Again, on the top, you have the menu bar, then you have a nice toolbar where you can connect and disconnect with the devices. Then we have something called a navigation bar, along with a device overview. So this giant white screen here is where you can create your projects. And on the right side is something called the device catalog, which simply shows you all the different kind of devices that we have that can work with the software, as well as something called device search. So if you physically connect a device with your laptop or your network, you can see it here, as in my case. And what essentially you can do is drag and drop it on the device overview screen. And while it is loading, on the bottom, you can see another thing which is called the task list. So this is also really helpful because whenever you have some kind of an error that might happen on your device, the task list very precisely shows what needs to be corrected, and you can go accordingly. All right, so now the sensor displays on my overview, and you have some basic information regarding the device, but what you want to do is open the device configuration. Once you click on that, your device configuration page shows up, and I have multiple screens, so let me drag it onto this one. So you should be able to see the actual device programming page now, and the very first thing is overview. And on the right side, you can literally see the measured data and the physical device in the camera. You can see probably with my hand here. And if I move my hand closer, you can see it moving. So it's live. In the overview, how we typically program these devices, again, I want to just show the point here that how intuitive it is to set up. First thing is, like, you can define a project name. If you have multiple devices, it's really good to set all these parameters up. And next is device information. This shows you the model number and other information regarding it. Next thing on the programming tab is hardware overview. So whatever device you connect, you can see it here along with the system plugs. And like I said before, we have different system plugs. We also have variants where you can have Ethernet connector to it. So you would also see those here if you have them. But I have the basic one, which simply just has IO. Next step in the tab is the configuration tab. And in configuration tab, you can just see the projected device, which is current configuration on the software and the actual configuration on the device itself. If there's a mismatch of the checksum, you can just read everything from the device and get it on your project here. So you can make changes accordingly. For me, I already have it here. I don't have any special configuration there. Next thing is identification. Again, if you have a project with multiple devices, this helps. You can define each device specifically and describe its function, as well as give it the application name. All right, this is where the actual programming starts. So this is called application tab. In this, you can define whether your safety scanner is being used for a stationary application or it is a mobile application. And it changes the algorithm accordingly. So for my case, I have a stationary application. Next thing is to define the language. I have like 6 options here. And then lastly, you can also select the display alignment. So let's say you have it mounted upside down, then you can also select upside down and it will change the display accordingly. Next tab is monitoring plane. So now this is where you define what kind of a safety application you have. You can select it between 3 of them. So first is the most common one, which is horizontal area protection. And then you have something called access protection, which is like you make a virtual wall. And has this point protection is again a vertical application, but you're trying to detect somebody's hand through it. And I'm just going to keep it basic. Let's do a horizontal one. We also have something called reference contour monitoring. I'll go over it in the next step, but let's talk about object resolution first. So this is the part where you defined what's the minimum object size that you're looking for to trigger the safety protocols. So you can do hand, which can be 20 or 30 millimeter, or even 40. Leg ankle detection, which can go from 50 to 70, and we also have body detection, which is more prevalent in obviously vertical axis protection, because we are detecting bodies there. And another thing to notice here is, like, it's a very interactive software. On the right side of it, you can literally see the changes that each of these parameters make to the device response time, as well as the protective fields. So in case of, let's say, leg, you would see that my protective field goes up and my response time gets better. And it says, I mean, the response time is 70 milliseconds right now. And if I do multiple sampling from 2 to 6, then you will see the response time change. And what multiple sampling rate is, it's the minimum number of times that the scanner scans for an object and looks for that object at that location. If it sees it there, then it triggers an output. And this is really helpful if you have a very dirty environment. Let's say if you have a lot of objects flying in, or something is happening in the environment all the time, and you can have a higher multiple sampling rate so that you do not get false trips. So let's go with hand and detection, and let's go 2 as a multiple sampling rate. Once you define that, the next objective is to set our fields. So this is the scanner's top-down view. I can just zoom in right now. And if you see on the camera too, if I move my hand in front of it, you will see that that's my hand coming in. And I can go back here. And essentially how we work with scanners is that we define protective fields here. Again, you have this toolbar here, and then on the right side is where you define these fields and field sets. So first thing is you have to define a field set. So you can have multiple field sets. And if you have a very dynamic application, you can switch between these different field sets. And in each field set, you can have multiple fields. So for the demo application, I'll set it for 2 fields. And how safety scanners are defined is you can either have a protective field or a warning field. And ignore the contour one right now. I'll go over it after this. So for protective or warning, what you do is protective field is where the safety protocol is triggered and the device shuts down the potential hazard. And then warning field, what that does is it gives out some kind of a warning signal, which you can connect to some kind of a buzzer or a light, or just get some signal to your controller to basically tell your operators to, hey, we are moving too close to the potential hazard. And if I go further down, there might be downtime, because the machine is obviously going to shut down as soon as you enter the protective field. So let's define the protective field first. So let's say and you have these tools here on the top. You have a nice drawing polygon tool where you can create multiple points based on if you have a very specific location you want to monitor, or you can use these simple rectangular or circular tools. So for my application, let's say my hand, if I go further inside from this position, I want the protective field to be triggered. And all I do is click on that point and drag it and drop it here. And for the warning field, I just click on field 2, and I go down in field type and select warning here. And again, I can use multiple tools that, again, I like it. I'll keep it simple. I'll just use the rectangular one. And this time I'll just draw this, and yellow simply represents the warning field. And that's pretty much it. And you're set up with your fields in no time. And another good thing to note is that you can define your resolution as well as your multiple sampling rate individually based on each field as well by clicking on it if you want. All right, so before I go further in, I also want to talk about another thing which we were supposed to. So there's also something called reference contour monitoring. So what if I turn this on, this checkbox brings a new tab here. Essentially, what this thing does is that it reference contour field is nothing but something to just make your application tamper proof. And it's really effective for those vertical applications so that nobody in the I mean, none of your operators or maintenance team can play around and try and tamper the device so they can have easy operation or just make it easier for them, but it becomes a potential hazard, which again, in non-contact, let's say non-contact safety switches, you have those magnetic ones, right? So some operators can just have a magnet, stick it to it, and they can bypass it. And hence, what contour reference does is that in your environment, let's say you have some kind of a unique spot which you know that the scanner is always supposed to see, you can use that in the environment as a reference. And hence, the scanner always needs to see that. And if it does not see it, it's going to go in off state. And hence, it's not going to let the device work. And for that, again, it's really simple. All you do is click on the draw contour line. And on the top, there's a nice example of it as well. So in this frame, you can simply draw the right side of the frame as a contour field. And all you do is click on this here. In my application right now, I have the background as the wall. So I can just click here and drag it here, double click, and this simply just becomes my reference contour field. Now, if I change the position of my scanner, it goes away from it and it's not going to trigger, and it's going to trigger an alarm for it or any kind of an output I want. But I'm going to turn it off. And we already have our field set here for warning and protective. Next step is IO. So this is where you can define the pin callout. So in my case, I have the IO version. So it's a M12 8-pin connector. And on the right side, you have these signals, which is outputs and inputs. So one thing to note here is that your output OSSD always goes on your pin 2 and 4, and you literally just have to click on it, drag and drop it. And that's how simple it is to set the safety output. In terms of defining your other pin 5, 6, and 7, you have a lot of options here. So now these are capable of both inputs and outputs. So an example of output can be a reset required warning, where you get some kind of a signal there, or you can do monitoring results. Like in my case, I would probably want to do a monitoring result, which is just like a high-low output, and I can connect this to my warning field. If somebody gets too close, it just triggers some kind of a buzzer or a stack light and tells the operator, hey, getting too close. And in terms of inputs, you again have multiple options. You can do EDM, you can do a reset, you can even do sleep mode. In sleep mode, you simply turn off the scanner, and then you can also do restart device. And on the bottom, you have something called properties, and this is where you define if you want to have a manual reset or you want automatic restart of the device. So all that can be defined right here. So in my case, like I have one protective field and one warning field, and protective field is obviously connected directly to the OSSD channel, the pair here, and my warning field, I'll connect it to pin 5. Next is monitoring cases. So now this is where you define different kind of monitoring cases. In my case, I just have one. And as mentioned before, you can have multiple of them. If you have a dynamic application, if your environment constantly changes, if you have different things going on, you can trigger different monitoring cases as well. And to define that, all you do is click on it, drag and drop it. Software is again very intuitive. On the bottom, you can see all the notes here, which simply tell you what needs to be done. And here, the first thing pops up here is that I need to define my safety output. For that, it's OSSD channel, so I'm just going to define it. This is the one that's supposed to trigger safety output. And my warning field, as you can see, I have connected it on pin 5, which is 1 here. And that's all I have to do here. If I had more monitoring cases, I could have just clicked on this, and then based on complementary or end function, I could change that. Once you do that, you can go to simulation. So what happens here is you can check if it's working according to your application. So like you can simulate an object. So let's say the object enters the warning field. I can click on it. You can see the warning field cuts off my path too. So each field is connected to a cutoff path. And you can see it right here on the top. Cutoff path 1 is to my protective field, and warning field has cutoff path 2. And you can test it here. And once tested, all you have to do is transfer that to your device. It will require you to put in a password. Once you put in the password, it will start the transfer of the configuration. Then it's going to ask you if you want to verify it. It also generates a nice report for it, which is right here. It shows you how your configuration was, and if it's based on the risk assessment that you already did, then it's good to go. You press on the verify button, and that's pretty much it. Now, if you see on the diagnostic tool here, or even in the camera, so these are my cutoff paths. So right now I have monitoring case 1 here, and you will see as soon as I bring my hand closer to it and I enter the warning, the cutoff path 2 goes low as we want it to, because it's going to trigger the warning field. And as I go further in, the dual channel, my OSSD output turns off, and it basically is working to the required needs. And that's pretty much it in terms of the software demo. If you guys have any questions, Kyle, I think you can take in questions now.
Awesome. Thank you, TJ. Thank you for the presentation. Yeah, like TJ said, we are now opening things up for a short Q&A with our last few minutes here. So if you have any questions, please let us know. We actually got one that came in during the presentation. So, okay, here we go. All right, TJ, can we change configurations over the network, or do we always have to connect to the safety scanner directly?
So you can change it over the network. And we do have, again, those system plugs which have the Ethernet protocol, Ethernet plugs. But the thing is, you'll have the device cannot be in an on state. So the device will turn off and then restart again. And while you're changing it, it's not going to monitor anything, So it can be done, but you have to you'll have downtime that time.
Okay. All right, we got another one here. How many protective fields can can I set in the NanoScan 3?
So that generally depends on the model you have. So we have 4 simultaneous that we can do, but on the newer ones, I'll have to double check if we can do more than that. But on the basic ones, we can have like 4 simultaneous and 2 on the core one variant. But I can double check on that. If you can just send me the information for whoever asked it, I can reach out to them as well.
Okay, yeah, we'll do. And then lastly here, what is the difference between IO and CIP safety model on Microscan 3?
So IO is your simple hardwire variant, in which you'll have to connect. You'll probably disconnect outputs either to a safety PLC or a relay. But the safety one is more of the industrial ways, industry protocol, right? That is the Ethernet IP one. So more commonly used with the Rockwell and or even a FANUC robot. They do talk SIP safety, and it's again Ethernet based protocol. So that's the difference.
Awesome. All right, and I think that does bring us here to our time. So thank you, TJ, and thank you to everyone who attended. If anyone would like to review any portion of this webinar, a recording will be available on our YouTube channel and on our website, enm.com, once available, and you will also be receiving a copy of it via email. I want to thank everyone for attending and wish you all a great day.
Thank you, guys.